Okay, so everybody should have their anchor chart that says relating division to multiplication at the top. And we are going to finish it. We're going to fill it out together. Okay. So, this whole lesson that we're doing today is about relating multiplication and division. You guys learned last year that multiplication and division are inverse operations. Does anybody remember what the word inverse means? If they're inverse operations, what does that mean? Kingston? Opposite. They're opposite. What else? What other two operations are inverse operations? What other two are opposite? Zadie?
Addition and subtraction.
Addition and subtraction. So just like addition and subtraction are inverse operations, multiplication and division are inverse operations. So that's how they are related. That's what they have to do with each other. They are opposite. So multiplication is opposite of division. And we're going to see what that looks like when we do this anchor chart and then when we do our lesson 1. So first, we need to define a fact family. Well, a fact family is, ooh, man, really? I think I had it open too long. A group, I might have to change, but it might get better. A group of 4 multiplication and division facts that use the same numbers. So fact families are groups of multiplication and division facts that use the same numbers. You may be thinking, how is that possible? Because division is going to have a smaller answer and multiplication is going to have a bigger answer. Well, let's look. We're going to use this word problem to help us see that multiplication and division are related because they're opposite, but not only are they opposite, they use the same numbers. They can use the same numbers. So let's read the problem. Read in your head while I read out loud. Justin is putting away 24 basketballs after practice. He puts them on a rack that has 3 shelves. How many basketballs can he put on each rack? Well, we see our question is, how many basketballs can he put on each rack? We're looking for the word that comes after how many or how many more or whatever to see our unit. In this case, it's basketballs. So we know when we're rereading the problem, we're looking for a number of basketballs. Then it says, can he put on each rack? If we see the word each in a question, that means we are doing multiplication or division. Whatever comes, so basketballs is the unit that our answer will be. Whatever comes after the word each, in this case rack, is the other number. Because in multiplication and division, our numbers that they give us are not going to represent the same thing. That only happens in addition and subtraction. In multiplication and division word problems, we're looking for numbers that represent 2 different things. Because I can't take a group of apples and divide them into groups by apples. Because normally if I'm taking something like apples, I'm going to figure out, okay, how many are in a basket? That's our basket. It's terrible. I can't figure out how many apples are in each apple. Does that make sense? No. How many apples are in each apple? Well, each apple is just 1 apple, so that means there's 1 apple in each apple. But if I'm trying to say Here's my apples again. I have 6 apples. I put them into groups of 3. How many apples are in each group? Well then, I don't need an answer. I'm not dividing or multiplying apples by apples. I'm dividing or multiplying apples by the group, by how many are in each basket. So, this is multiplication and division word problems are a little different because you're not just looking for the number and then the unit. You're also looking for a number and whatever comes after each, typically. So let's reread the problem and look for a number of basketballs and a number that goes with rack. It may not be blank racks, but it'll go with it. So Justin is putting away 24 basketballs after practice. Well, I see my unit. My unit that my answer will be in. 24 basketballs. He puts them on a rack. Ooh, I see the word. That means my other number. But I don't see a number before it. So let me keep reading if I look to see if I can find a number that means the same thing. That has 3 shelves. Well, I know racks have shelves. So 3 shelves must be my other number. I have 24 basketballs on 3 shelves. How many basketballs can go on each rack? Equally. So first, what I want to do is I want to draw a picture to figure it out. Once I draw that picture, then I can make my problems. So what I'm going to do is I'm going to start putting my 24 basketballs on racks. But I'm not going to do this. Everybody watch what I am not going to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Because do I have the same amount of basketballs on each rack?
No.
Carla?
No.
No. So does that help me figure out how many basketballs can you put on each rack? I'm trying to find one answer. This gives me 3. Well, he can put 1, 2, 3, 4, 5, 6, 7, 8 on one. He can put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the other. And 1, 2, 3, 4, 5, 6 on the other. That's 3 answers. I'm only looking for 1. Bless you. So when I'm drawing a picture, what I have to do is do it equally. That's going to look like this. 1, you can do this with me. 2, 3. I'm going to put 1 at a time on each rack. So I've got 1, 2, 3 until I get to 24 basketballs. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Am I going to keep going?
No.
No, I only have 24 basketballs. I can't put more when I don't have more. So now I can figure out what my equations look like. So first, for this first one, well, I have 3 shelves. I have 24 basketballs. Let's count how many I have on each rack. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 3 shelves. There are 8 basketballs in each shelf. I have 24 in all. That means here, on the 3 shelves, there were 8 basketballs on each shelf for 24 total basketballs. I repeated 3. I repeated 3 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Does everybody see that? Now if I look at the next one, well, I have 8 basketballs on each shelf. Did my number of shelves change? No, I still have how many shelves, class?
3.
3.
3.
Did the total number of basketballs change?
No.
Nope.
Nope.
So this time, I repeated 8 3 times. I have 8, 1, 2, 3 to get 24. Now, division. I start with the total basketballs. I divide it by the number of basketballs on each shelf. Did the total number of basketballs change? No. I still have 24. Did the number on each shelf change? Did the number of basketballs on each shelf change? No, I still have 8 basketballs on each shelf. So that still means, do I still have the same number of shelves? How many shelves do I have? Michaela? 3. So that means I took my total 24 basketballs, I broke them into groups of 8. So here's a group of 8. And there's another, and there's another. How many groups of 8 do I have now? Colin?
3.
3. I have 1, 2, 3 groups of 8. So 24 basketballs divided by 8 on each shelf equals 3 shelves. Now let's look at the last one. Did my total number of basketballs change? Class?
No.
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 That fits for that too. Did the number of shelves change?
No.
No, I still have 3. Did the number of basketballs on each shelf change?
No.
So I still have 8 on each shelf. Well, let's check that. If I circle groups of 3. 1, 2, 3, 4, 5, 6, 7, 8. I circled groups of 3 basketballs. How many groups did I have, class?
8.
8. So do you see, I made 4 different problems with the same 3 numbers. That is a fact family. And that's what we're going to be talking about today, because division and multiplication are related because they're opposite. And we'll see some more of that. So there are 3 shelves, and there are 8 basketballs on each shelf. 3 times 8 equals 24. 8 times 3 equals 24. 24 divided by 8 equals 3. 24 divided by 3 equals 8. So make sure when you are doing multiplication, your answer is the largest number, just like addition. When you're doing subtraction, your first number is the largest number. When you're doing division, your first number is the largest number, just like subtraction. That's another thing that's related that we're going to talk about later. Okay, so does everybody get this? Okay, put that to the side. Go ahead and open your math book up to page 135. Helper number 1, please sanitize, erase, sanitize. So now, let's look more about why we have fact families. So go ahead and read the sentences under the title, Carla, loud and slow.
Can use models to represent multiplication and division. Multiplication and division are opposite or inverse operations.
Good. So that's what we just talked about. They are opposite operations. The math word for opposite is inverse. So multiplication and division are inverse operations. You know with multiplication, you end with the largest number. In division, you begin with the largest number. Beginning and end are opposite words, just like multiplication and division are opposite or inverse operations. Okay, so let's look at example 1. Okay, finger or pencil on example 1. And read in your head while I read out loud. We have a word problem, so we're going to read it once to find the question, then we'll read it a second time to find the important pieces of information. Felix and Mei Ling went to an arcade. They played 4 games that cost $3 each. What was the total cost? So we have what was the total cost? That is our answer. The word that comes after how many or total is the unit that our answer will be in. But if we say cost, are we going to say like 7 cost? What are we going to say? What's the unit going to be? Cost tells us, well, we're going to use a specific unit, but not the word cost. Cullen?
$8 sign.
Dollar sign. Good. Now let's reread it to figure out, okay, well, what are our pieces? We see, let's see, Felix and Mei Ling went to an arcade. Is there anything important in that sentence? No. That's just, this is what's happening. They played 4 games that cost $3 each. What word do we see that tells us we're going to be doing multiplication or division? Victoria. Each. Each tells us we're going to be doing multiplication or division. We don't really know which one yet. So now we know if we have multiplication or division, we're not going to have numbers that represent the same thing. We're not going to have apples and apples or dollars and dollars, because you can't divide, or you can you take $1 and repeat it $1 times? Can you take $20 and divide it $5 times? Can you repeat can you take $20 and divide it into $5 groups? Can you? Is $5 groups a thing? You guys are just saying no because you know that the answer is not yes. You have to think about it. Just because when there's only 2 options and I say you're wrong and then you're like, okay, well it has to be the other one. You're giving me the right answer, but are you doing it correctly? Because do you know why? If you don't know why, then that really doesn't matter at all. I can't break anything into $5 groups because $5 is just an amount of money. You can't break something down into an amount of money group. You can break it down into groups of $5, but I can't break it down into $5 groups. I can break it into 5 groups or in groups of $5, but I can't break it down into $5 groups. $5 groups is not a thing. So, let's look at that sentence again. They played 4 games that cost $3 each. Well, I see the number 4. 4 represents games. That's the number of games. Then I see $3. That's the amount of money that each game costed. Can I add games plus dollars and end up with a group? Can you do that? Zari?
No.
No. Because then what would I put the unit? 4 plus 3 is 7. 7 games dollars. Is that a thing? Is games dollars a thing? No.
No.
Games dollars is not a thing. Games are a thing and dollars are a thing. So another way we know we have to be doing multiplication or division is that we have 2 separate units. So we're taking the 4 games. Each one costs $3. So step 1. We're arranging counters in an array. This is our array. You're going to draw your counters because I don't have enough counters for everybody. I only have like 30 counters. Arrange counters in an array with 3 rows and 4 columns. Draw the counters in the chart. So we have 1, 2, 3 rows and 1, 2, 3, 4 columns. So let's draw our counters. We've got 4 columns and 3 rows. The columns represent the number of games, because we know that there were 4 games. The rows represent how much money. So each of these games costed this much. We can imagine that each of these counters is $1. How many counters are there? Colin, let's count them.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So how many counters are there?
12.
12. There are 12 counters total. What we did was we saw the 4 games. 1 game, 2 games, 3 games, 4 games. Each game cost $1, $2, $3. So that means we repeated those $3 1, 2, 3, 4 times to get a total of how many dollars? Class?
12.
$12. So now we're going to write a multiplication sentence. We're going to start with the number of rows. How many rows are there? Remember, rows go side to side, columns go up and down. How many rows are there? Zadie?
3.
3 rows. How many columns are there? Remember, columns go up and down. Smith?
4 columns.
4 columns. Our total, how many counters we had in all is what? Michaela? 12. So that means 3 times 4 equals 12. 3 rows of 4 is 12 in all. 3 rows of 4 counters is 12 in all. If we take 3 and we repeat it 4 times, we get 12. Everybody needs to know this. This is very important. The numbers that you are multiplying together are called factors. It's like addition, where we have add-ins. Our 2 pieces that we're adding together don't have a different name. It's the same with multiplication. The 2 pieces that we are multiplying do not have a different name. Why do you think that is? Why do you think it is that our factors don't have a specific name for where they are in the problem? Why is there not a different name for the first factor than there is from the second factor? Carla?
Because they both are factors and they both are in the same arrangement.
They're not, because I don't have a different name for the first factor than I do for the second factor, just like in addition. Do I have a different name for the first addend and the second addend, class? Why?
No.
Why? Why are there not different names for the addends in a math problem, in an addition problem? Come on, guys. We just did this chapter. This math is not going to mean much to you if you just let it go out of your head on the other one. What reason can we add numbers in any order? Commutative property. Addition and multiplication are pretty much the same. You're taking groups and making a bigger number. So why is there not a different name for the 2 factors? If the addends are the same, because it doesn't matter what order you add them in, and so that's why there's not a different name, why is there not a different name for the first and second factor? Victoria?
Because if you switch them up, they're still going to equal the same number.
If you switch them, you say 4 times 3, are we going to get a different answer?
Nope.
So does it matter what order you put the factors in?
Nope.
So do we need to know, hey, your first number is called something different than your second number because you have to put the first number in that place, otherwise it won't work? No. Factors do not have different names for the first and second number, just like addends, because it doesn't matter what order you do the problem in. It's still going to equal the same thing. The answer to a multiplication problem is the product. Come on, guys, think. Some of you are just sitting there. Some of you are sitting there like, but you're not actually thinking. You're just trying to make it look like I think you're thinking, but I can tell when you're thinking and when you're not. Because when you're thinking, this is what happens. It may take a second, but you get there if you actually take the time to think. You will get there. But some of you are just like, but you're not actually thinking. You're just making it look like it. Because if you were thinking, you would get there. Okay. Now we need to make a related division sentence. Well, we know in multiplication we end with the largest number, but in division we start with the largest number. So we're going to start with the total. What is the total? Kingston? 12. Here we're going to divide by the number of rows. How many rows do we have? Carla?
3.
3. And then we're going to end with the number of columns. How many columns do we have? Smith?
4.
4. Because if we take 12 and we break it into 3 rows, 1, 2, 3, how many are in each of those rows? Colin?
4.
4. So the total cost was how much? We took the $3, we repeated it for 4 games, and we got how much money? Zadie?
$12.
$12. Oh wait, let's look at this division problem. So we have names. We have a separate name for the first number in a division problem. It is the dividend. The second number in a division problem is the divisor. So we take the dividend, which is the first number, and we divide it by the divisor, which is the second number. And in the end, our answer is called the quotient. Why are there different names for the first and second number in a division problem? Michaela? It matters what order they're in, because just like subtraction, Michaela, which number has to come first in a division sentence? The biggest number. Because you're taking that bigger number and you're breaking it down into groups. I took my $12 and I broke it down into groups. In this problem, I broke it down into groups of 3. And then I'm seeing how many were in each group. There were 4. Okay. So there's example 1. Now these aren't the only problems that we can make. We can make 2 more problems with this number. Let's see how we are with these numbers. Let's see how we can do that in example 2. Okay, everybody. Well, wait. Let's read this sentence at the top first. Zadie, loud and slow.
A fact family is a set of 4 related multiplication and division facts that use the same 3 numbers.
Good. So underline that because that is very important to know. A fact family is a set of 4 related multiplication and division facts that use the same 3 numbers. So just like what we did with the basketballs on the shelves, we came up with 4 problems. Bless you. We multiplied the shelves by the number of basketballs on each shelf to get the total number of basketballs. We multiplied by the number of basketballs on each shelf by the number of shelves to get the total number of basketballs. We divided the total number of basketballs by the number of shelves to get the number of basketballs on each shelf. We divided the total number of basketballs by the number of basketballs on each shelf to get the number of shelves. That was 4 problems using the same 3 numbers, 24, 8, and 3. Here, finger or pencil on example 2. We're going to create a fact family, a set of 4 related multiplication and division facts that use the same 3 numbers. So when I see everybody's finger or pencil on example 2, I will continue. and her family made an array of buttons. Write a fact family for the array. So there's our question. We're writing a fact family for an array. We already know our fact family is going to have multiplication and division because we're working with multiplication and division, fact families, not addition and subtraction. So now we have to look at this array. Remember, an array is items that are arranged in rows and columns. So here we have our buttons. That's our item. They are arranged in rows, side to side, and columns, up and down. So first we need to figure out, okay, how many rows and how many columns? Zari, how many rows do we have?
3.
3. We have 3 rows. We have 1, 2, 3. Now we have to figure out how many columns do we have? Victoria? 4. 1, 2, 3, 4. Once we count all of them, Smith, help me figure out how many buttons we have. Count them with me.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Good. So all together, how many buttons do we have?
12 buttons.
12 buttons. So we know the 3 numbers in our fact family will be what? What will the 3 numbers in our fact family be? Carla?
4, 3, and 12.
4, 3, and 12. So we have to figure out, okay? How can we make that into a problem? Well, let's start with multiplication. Which number are we always going to end with in multiplication? Don't tell me 12, because it's not going to be that every single time. Zari, which number are we always going to end with in multiplication?
A bigger number.
The biggest number. So for our first multiplication problem, what's our product going to be?
Sorry, I couldn't hear you.
In our first multiplication problem, what is our product going to be?
3.
What is our product going to be? Zari, what's the product in a multiplication problem?
It's going to be 12.
12, because our product in a multiplication problem is the answer. Now for this first one, would you like to start with the rows or the columns? Does it matter which one you start with?
No.
No. So for this
Just like
first
addition.
multiplication problem, which one would you like to start with? The rows or the columns?
Columns.
How many columns are there?
4.
4. Now are we going to multiply that by the number of columns or the number of rows?
Rows.
How many rows are there?
3.
So our first multiplication problem is 4 times 3 equals 12. If we take our 4 columns, 1, 2, 3, 4, and we repeat them 3 times, 1, 2, 3, we get how many buttons, Zari?
I have kind of an outage. What did you say?
Okay. So Zari, maybe use different headphones, okay? Because we got to go fast, okay? So if I take my 4 columns and I repeat them 3 times, how many buttons do I have altogether?
12.
12. Okay, our next problem, we have another multiplication problem. Wait. So I always know my product is going to be which number? Zadie?
The bigger number.
The biggest number. So for these 3 numbers, what's the product of this multiplication problem going to be?
12.
12. Now we already started with the number of columns, so this time we have to start with the number of,
Rows.
are we going to multiply it by the number of rows or the number of columns?
Number of columns.
Which is how many?
4.
4. So if I take my 3 rows, 1, 2, 3, and repeat it 1, 2, 3, 4 times, how many buttons do I get?
12.
12. Okay, now division. In division, I have to start with which problem? Where does my biggest number go in division? Cullen.
In the first box.
At the beginning. It's also called the what? The first number in a division problem is also called the what?
Dividend.
The dividend. So for our first division problem, I'm going to start with what number?
12.
The total number of buttons. Now, do I want to divide it by the number of rows or the number of columns? Or does it matter?
Doesn't matter.
It doesn't matter. So which one would you like to do?
Rows.
Rows. How many rows are there?
3.
And my answer, would it be the number of rows or the number of columns?
Number of columns.
How many columns are there?
4.
So if I take my 12 buttons and I break them into groups of 3, 1, 2, 3, how many buttons are in each group?
4.
4. 1, 2, 3, 4. Now, second division problem. Do I start with a different number than the first one? Victoria.
No. Also, aren't we supposed to, so there's some colors in each place and the numbers are highlighted with the color. Aren't we supposed to put the number of this color?
That's my book. Oh, okay. My book does not have that.
Because our book does.
Okay,
And
so
it's
we have
on
to
there.
go back. My book does not have that. That must be something that they changed in the new version, and I can't really tell the colors. So yes, Zadie.
I did that.
Okay, so let's go back. I cannot tell. Oh gosh. Let's go back. I can't really tell what colors are which. So you're gonna have to help me. Okay. So, sorry, Zari. Let's go back to the one you did the first one, correct?
Correct.
Correct. Okay. So I can't tell what color is 3 rows highlighted in. Sorry.
It's in pink.
Pink. This is my note. You don't have to write this because I can't tell. What color is columns in?
Blue.
Blue. And what color is buttons in?
Green.
Green. Okay. And now I should be able to tell which one is which. So, okay. So for our first one, Zari, we have to start with which one? The rows or the columns? Because we know our
The
answer is going to be the
rows.
total. We know in multiplication our answer is going to be the total. So, what color do we start with, Zari?
The rows.
The rows. How many rows are there in this problem?
3.
In this array, I mean. Okay, then we multiply it by the number of,
Columns.
how many columns are there in this array?
4.
4. And we know with multiplication, our product is always the answer. Our factors are the number of rows and columns, doesn't matter what order. Our answer, our product, is the total number. How many total buttons do we have, Zari?
12.
12.
buttons.
Good. Now for the second one, who helped me with that one? Zadie. Again, we start our factors are the number of rows and columns. Which one do we start with here?
Columns.
How many columns are there?
4.
We're going to multiply it by the number of what?
Rows.
How many rows are there?
3.
And our answer is always the what?
The bigger number.
Well, the total. Our product, I already said our product. So our factors are the number of rows and columns. Our product is the, who can help her out? Michaela. The total number of objects. So what's the total number of objects in this array?
12.
12. Okay, we can go on a little longer because we have, after your spelling test today, I scheduled 30 minutes and then we have an extra 30 minutes after, but we're not going to need 30 minutes for the spelling test. So, let's keep going. We'll go for another, I think 20 minutes.
Miss Bellis, the ones in division somehow we did that right.
I guess it's just a coincidence. But is a coincidence, does that mean that you know how to do it?
No.
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 So you have to make sure it's not just a coincidence that you're right. You're right because you know what to do. Okay, who helped me with this one?
I did.
Cullen. So in division, we always start with the number of, our dividend is always the
Total.
total number of objects. So how many, what is the total number of objects for this array?
12.
12. And then we can either divide by the rows or the columns.
It is the
In
rows.
this case, we're going to divide by the number of
Rows.
rows, which is how many?
3.
And then we're going to get, our answer is going to be whichever one we didn't divide by. So we divided by the number of rows, so our answer is going to be the number of
Columns.
columns.
I did that because I knew it was right.
So what that means is we took our 12, we broke it into groups, into 3 groups. 1, 2, 3 groups. Our answer is the number of objects in each group. 1, 2, 3, 4. Now, for the last one, who helped me with that? Victoria. In division, we always start with the, which is the dividend, which if we have an array is the, who can help her? Colin?
Total.
The total number of objects. In division, if we have an array, we always start with the total number of objects. So our dividend in this problem is what? 12, because that's the total number of objects. Then we can either divide by the rows or the columns. In this case, which one are we going to divide by? The columns. How many columns are there? And then our answer is going to be the number of rows, which is how many? 3. Because if we take our 12 objects and we break them into 4 groups, 1, 2, 3, 4, how many objects are in each group? What? 3. We broke them into 1, 2, 3, 4 groups. There's 1, 2, 3 in each group. So now I'm going to show you what this problem looks like. Let's start with 3 times 4. We took, let's see. For 3 times 4, we took 1, 2, 3 rows, and we repeated them 1, 2, 3, 4 times. For 4 times 3 equals 12, we took 1, 2, 3, 4 columns, and we repeated them 1, 2, 3 times. For 12 divided by 3, we took our 12 objects, and we broke them into groups, into 3 groups. 1, 2, 3, oops, I did that wrong. Sorry, we broke them into 3 equal groups. 1, 2, 3. Then we counted how many objects were in each group. 1, 2, 3, 4. 12 divided by 4 equals 3. We broke our 12 objects into 4 equal groups. 1, 2, 3, 4. And then we counted the number of items in a group. 1, 2, 3. As long as our groups are equal, as long as we broke them into equal groups, we're going to have 3 in each group. Okay, let's look at example 3. So everybody, finger or pencil on example 3. Read in your head while I read out loud. Vanessa has 36 books to put on 4 shelves. The same number of books will be placed on each shelf. How many books will be on each shelf? So here's our question. How many books will be on each shelf? We have the word books. After how many? That means that's going to be our answer unit. It may not be the unit of the pieces of our problem, but we know our answer is going to be blank books. The word each tells us we are doing multiplication or division. We have the word shelf after the word each, which means shelf will be our other number. If you are not copying what I'm writing in your book, you are not helping yourself right now. So now that I'm about to move on, if now is when you're choosing to do what I just did in the book, Well, then you're not going to listen to what I say next. You need to be
Miss
doing it
Lois?
as I do it. Yes, sorry.
The writing is small for us to
Well, you can
see.
hear me, though. You can hear me. You're not necessarily just copying, you're listening and writing what I'm saying. We know how many books will be on each shelf is the question. Books comes after how many, so that's going to be the unit our answer is in, our answer unit. We see each, which means we're multiplying or dividing. We don't know which one. We have to figure it out. Do we know the total, or do we know the number of our factors? If we know the total, that means we're going to be dividing. If we don't know the total, that means we're going to be multiplying. If we know the total of number of objects in all, we'll be dividing. If we don't know the total number of objects in all, we're going to be multiplying. The word that comes after each is shelf. That means that's the other number that we're looking for. We're looking for a number of books, and we're looking for a number of shelves. If you have a word after each, that usually means you're looking for that word to be the other unit. So that means we're looking for a number of books, and we're looking for a number of shelves in our problem. So let's reread. Vanessa has 36 books to put on 4 shelves. In that problem, I see a number of books, and I see a number of shelves. So I know 36 books is going to be important, and 4 shelves is going to be important. My next sentence says the same number of books will be placed on each shelf. All that sentence is telling me is that we're going to have equal groups. If we have equal groups, that means we can multiply or divide. All that sentence is telling me is, hey, you're going to be able to multiply or divide because we have equal groups. We can only multiply or divide when we have equal groups. Okay, so now that means we know the total number of books. We know there are 36 books in all. She's not going to end up with more books than 36 because it says she has 36. Are we adding or making more books in this problem? Is there anywhere where that says the books are going to get bigger? The number of books is going to get bigger. Zadie?
No.
No. So that means we have to be dividing. We know there's 36 books. There's 4 shelves. We're trying to figure out how many books are going to go on each shelf. Can we end up with more than 36 books on each shelf? No, because there's only 36 books. So that means we know our total. Our total number of objects is the dividend, the first number in a division problem. So that means we're trying to find 36, and we need to divide by the number of groups. Well, we know there are 4 shelves, and there's going to be objects on each of those 4 shelves. That means we're dividing it into 4 groups. So our division problem is 36 divided by 4. Now it says you can use a related multiplication fact to help you divide because you guys don't necessarily know how to do division yet. You don't know how to do division yet, but you should know your basic facts. So that means you can figure out, okay, they're inverse operations. That means 36 divided by 4. Well, 4 times something has to be 36. So we're trying to figure out. We don't know how to do 36 divided by 4, but you do know how to do 4 times something equals 36, or you should, because that's a basic fact. And that's the whole point of 3rd grade math, is to learn your basic facts. So we have to think, 4 times something equals 36. So, 4 times what equals 36? Who knows their math facts? 4 times what equals 36? Zari.
9.
9. 4 times 9 equals 36. So, Zari, 36 divided by 4 has to equal what?
9.
9. Because we know, because of fact families, okay, well 12 divided by 3 equals 4. That means 3 times 4 equals 12. They're inverse operations, so they're backwards. So Zari, Vanessa will place how many books on each shelf?
9 books on each shelf.
9 books on each shelf. Good. So do you see why you need to know your math facts?
Yes.
Because if you know your math facts, that's just off the top of your head. And we're going to start putting all these together where you have a problem like this. And you solve it because you know your basic facts. 9 times 8, 72. 9 times 2, 18 plus 7, 26. 9 times 7 is 63 plus 2 is 65. 9 times 4 is 36 plus 6 is 42. Then you'll learn why you have to put the 0 later. 6 times 8 is 48. 6 times 2 is 12 plus 4 is 16. Bring down my comma. 6 times 7 is 56 plus 1 is, no wait, not 56, sorry, 42 plus 1 is 43. 6 times 4 is 24 plus 4 is 28. 2 plus 0 is 2. 6 plus 8 is 14. Regroup the 1. 5 plus 6 is 11. Plus 1 is 12. Regroup the 1. 3 plus 2 is 5. Plus 1 is 6. 4 plus 8 is 12. Regroup the 1. 2 plus 1 is 3. And you'll be able to do that.
I'm stuck.
If you know your basic facts, you can do this.
I'm scared.
Because no, don't be scared. Because all it is basic facts. And just repeating. But you have to know your basic facts. This is not hard at all once you know your basic facts. And this will be chapter 5. We don't have time to go to it right now. But this will be chapter 5, and you can do it. You just have to know your basic facts. Everybody gets scared, but once they know their basic facts and they see all it is just basic facts and putting them together, it is not hard. So study your basic facts. That is why we are having a basic facts test. Because as long as you know those, you will be able to do that. Maybe not as fast, but I've been doing this I started this in 2nd grade. I started multiplication in 2nd grade. I was 7, I'm 31 now. That was 24 years ago. But you will be able to do this in like 3 months. You will be able to do this. You have to know your basic facts though. If you don't know your basic facts, you're not going to be able to do this. But your basic facts is just memorizing. All those things where I said 9 times 8 is 70 is, oops, I messed up. Oh no, I have it right there. Is 72. You need to be able to do that. You can. You just have to memorize. Okay. So let's move on to the guided practice. We have 7 more minutes. That should be enough time. Helper number 1, sanitize, erase, sanitize. Let's look at the guided practice. Number 1, write the fact family for each array. So what we have to do is we have to figure out the number of what? Michaela, what do we have to figure out? The number of what for this number 1, this paint palette? The number of rows. How many rows are there? 3. We can see that because we have 1, 2, 3. So there are 3 rows. What else do we have to figure out, Michaela? How many columns? How many columns are there? 1, 2, 3, 4, 5, 6, 7. And then what other number do we need? We have the rows, we have the columns, now we need the Zadie, can you help her out?
The total.
The total number of paints. So what's the total number of paints, Michaela? We could count 1 by 1, but we already know what numbers are we multiplying together. 7 times 3. So what's 7 times 3? We could count them, but that would take longer than to just say 7 times 3 is, Zadie?
21.
21. So we know the total is going to be what, Michaela? 21. So that means we're going to use these 3 numbers to write a fact family. Well, first, when we multiply, do we multiply the rows and columns? Do we multiply the rows in the total? Do we multiply the columns in the total? What else? The columns and rows. So let's, with the first one, do you want to start with the number of columns or the number of rows? Our first multiplication, you're going to start with the number of, which is how many? And then we multiply it by the number of? The number of? We took our number of rows, now we have to, which is 3, we have to multiply it by the number of columns, which is, our product is going to be the, which is 21. So we have the number of rows, 3 times the number of columns, 7, to get the total, 21. Our factors are 3 and 7. Our product is 21. Okay, we'll let somebody else do this. Colin, our next problem, what is it going to be, multiplication or division?
Multiplication.
Multiplication. So Michaela multiplied the number of rows times the number of columns to get the total. What are you going to do?
Multiply the columns.
Which is how many?
7
Times the,
rows.
which is?
3
So our factors are 7 and 3. Our product is going to be the,
total.
which is?
21.
Good. Okay, our next problem, is it going to be multiplication or division, Ethan? Kingston, our next problem, is it going to be multiplication or division? Division. In division, we always start with the what? When we have an array, in division, we always start with the what? The answer? Do we start any problem with the answer ever? We end with the answer. But when we have an array, we have rows. Come on, Kingston, it's a pattern. It's the same thing we did. We have rows, columns, and the total. In division, we start with the what if we have an array? The total. So our dividend is the total. In this case, what is it? 21. And then we divide by the divisor, which can be either the what? It can be one of the what blank or one of the blank. Every single time, no matter what numbers we have. So we divide by the number of, or the number of, which one would you like to divide by? Which is? And then if we divide by the number of columns, our answer is going to be the number of, which is? 3. Okay, what do we have to do next? Multiplication or division? Carla, what do we do next? Multiplication or division?
Division.
Division. In division, we always start with the rows, columns, or total.
Total.
Which in this case is?
21.
So our dividend is 21. We already divided by the number of columns, so now we have to divide by the number of?
Rows.
Which is?
3.
And our answer is going to be the number of?
The number of columns.
Which is?
Is 7.
7. Very good. Okay, so we have our dividend of 21, our divisor of 3, and our quotient of 7. Okay, number 2. Kingston. First, before we can figure out our fact family, we have to figure out the number of what and what? And what? The number of columns, which is how many? 5. Now we have to figure out the number of, which is 5. That gives us a total of how many? Cullen, can you help him out?
25.
25. So now we start with what? Multiplication or division when we're writing a fact family? Multiplication. So we multiply the number of what by the number of what? 4 columns. So rows or columns by the number of? Do we ever multiply by the total? So we take the number of rows or columns and we multiply it by the number of? Who can help them out? We take the number of rows or columns and we multiply it by the number of Zari?
Shells.
We take the number of rows or columns, whichever one we choose, and we multiply it by the number of rows or columns, whichever one we didn't choose. So Kingston, would you like to start by multiplying the number of rows or the number of columns? Which one would you like to start with, the number of rows or the number of columns? Columns. How many columns are there? Which means we have to multiply by the number of, which is? To get what? The rows, columns, or total? Huh? The rows, columns, or total. Are we going to get 25 every time, no matter what numbers there are? This is why we've got to do these patterns, so that we don't have to talk about it again. But you guys just want to get to the end. You want to get to the answer so fast. Well, if you get to the answer so fast, you don't know the pattern, which means when you get a whole different set of numbers, you're going to be confused because you only know, oh wait, 5 times 5 equals 25. But you were just trying to get to 5 times 5 equals 25 that you forgot it's the number of rows or columns multiplied by the number of rows or columns to get the total. So you've got to remember, you've got to follow the steps and find the patterns to make it easier when you have totally different numbers. So Kingston, we multiplied the number of columns by the number of rows to get the total, which in this case is 25. Please fix the attitude. And please pay attention. Put the pencil down. That's not what's teaching you math right now. Now, Colin, I just multiplied the number of columns times the number of rows. If I multiply the number of rows times the number of columns, is that going to look different at all?
No.
No. So do I need to write it again?
No.
No. So if my number of rows and columns are the same, how many multiplication problems am I going to have, Colin?
1.
1. Which means how many division problems am I going to have?
1.
1. If you have an array and the number of rows and columns are the same, you don't have to write, again, well, 5 columns times 5 rows is 25, and 5 rows times 5 columns is 25. You don't have to do that. Just like you don't have to take the total, which is what, Colin?
25.
Divided by the number of rows, which is what, Colin?
5.
To get the number of columns, which is what, Colin?
5.
I don't have to, again, take the total number divided by the columns to get the rows, because it looks exactly the same. So if your number of rows and columns are the same, you only have to write one multiplication problem and one division problem. Okay, we will have time to do the independent practice later today. Go ahead and put your anchor chart in your math folder. Put your math book away. Get out reading, your reading textbook,